Okay, good evening. So last week we started the can I silence? Silence. So last week we started the lesson functions. Okay, silence. Arre. Okay, so last week we started the functions and I told you. Okay, no silence. Huh? So when there are mainly silence. There are mainly two things that we are asked to find. One is the domain, and the other one is to find the range of a function. So one thing is finding the domain and the other one is finding the range. And there is another one called codomain, but I told you normally, normally the codomain, we take it as the entire real number set. Because of that issue, that we won't be asking a question to find the codomain. So normally we only have questions to find the domain and range. So last week we completed the domain entirely and then we even started what is the range and how to find the range. So if I explain with this function, if you take that y is equal to x plus 1, a simplest function, I told you the domain is the set of values this independent variable x can take. So what is the domain? Domain is the value, the set of values this independent variable x can take. So normally what we do, we have to find the range of x or the set of x values such that y is real. Such that y is real. For this purpose, I told you, you have to check whether there is a square root in your function or whether there is a denominator. So I told you there are two checks that you have to do. Check whether there is a square root and check whether there is a denominator. And if there is a denominator, take out the values that makes the denominator 0, take out the values that make the denominator 0, because we don't consider that the denominator is equal to 0. That is not defined in maths. So if there is a denominator, it can't be 0. So take out the values that make the denominator 0. And the other one is check whether there is a square root. If there is a square root, the expression inside the square root should be a positive one. It should be greater or equal to 0. So I told you to consider about these two. So based on these two, you can write your domain. So when it comes to range, so what is the range? Range is the set of y values that make x real. The set of y values that make x real. So in this case, since we have subjected y, I told you y is equal to x plus 1. So you can clearly see when I substitute a particular x value here, I can check whether y is real or not. The reason that why I can do it is because y has been subjected here. So to find the range, I told you what is the range? Range is the set of y values that make x real. For that purpose, the first thing that we have to subject x. So when you subject x, x is equal to y minus 1. Okay, now when x is equal to y minus 1, it is clear. You can say, okay, when you substitute a particular y value, whether x is real or not, you can check that because x has been subjected. So same thing. So the same thing. When we were finding the domain, we consider that the denominator should be 0 and the square root should be greater than or equal to 0. The similar thing, when finding the range, only one additional step, you have to first subject x and then check whether there is a denominator. If there is a denominator, the denominator can't be 0. Check whether there is a square root. If there is a square root, the square root can't be equal to 0. So codomain is normally, if we are supposed to write the codomain, in case if a question is asked, what is the codomain of this? Just write that the codomain is the entire real number set because this is what they normally define as the codomain. Okay, so we have done few questions. Question number 1 in the tute. So entirely we have find all the domains in the functions, and I think we have even we have taken this range of 5 or 6 questions. So I'll just give one question to remind this and then let's go to the tute. Find the domain and range of this function. So y is equal to x squared plus 4. Find the range and the domain here. Y is equal to x squared. A small one just to remind the things. Find the domain and the range here. Find the domain and the range. A small one, y equals x squared plus 4. Okay, so what is the domain here? There is no any denominator, there's no any square root. So when there's no any denominator and when there's no any square root, the domain is the entire real number set. So here x is an element of the entire real number set. So this is the domain. But when to find the range, the first thing that you need to subject x here. So when you are subjecting x here, x squared is equal to y minus 4, which gives you x. You have to take the square root and you get that x is equal to y minus 4 square root. X is equal to y minus 4 square root. So after subjecting x, it's clear that there is a square root. So what is inside the square root? It should be greater or equal to 0. That means y is greater or equal to 0. So we get the range in terms of y. We get the range in terms of y. You can either keep it in the inequality format or you can convert into the set notation. Square bracket 4 and it goes up to infinity. So when it is the x, it's kept in terms of x. But when it is the range, we can keep the answer in terms of y. Clear? So this is x and this is y, what we get. Okay, now do question number 3 in the tute. Question number 3. Do question number 3, like main question 1 and then question number 3. Sub question 3 under the main question. Page number 15, silence. No, stop talking. Do the work. Sub question 3, main question 1. Find the range. We have taken the domains, no? So find the range. The domains we have taken. Find the range of that function. So first thing is you need to subject x here. So that is the first thing. You need to subject x. Okay, hands up who subjected x is. So here y is equal to x squared plus 2x plus 3. In hands up who subjected x here? Who subjected x? Okay, okay, to everyone. I'll give like 2 more minutes, others even try. Okay, the ones who do subjected it, just keep your hands raised up. I'll just come and check. Okay, silence, silence. Keep trying. I want you to subject x here. So subjecting x means x should be equal to someone else. X is equal to a expression. So you have to make x alone in one side. So that is what we mean by subjecting x. So here, we got y equals x squared plus 2x plus 3. No? So in previous ones, we have done the first, I think, first 6 questions in finding the range, except this one. In all those questions, you could easily take x to one side and then make it alone and then subject x. So I have seen like few have done, like many have done in the correct way, so that's good. But I have seen like some have done this in this way, they are taking 3 here and then we get x squared plus 2x. And if you take out x from here, you get x into x plus 2 is equal to x minus 3. I have just switched the sides. So when you take out x, x into x plus 2 is equal to y minus 3. So then they have divided by this, which makes x is equal to y minus 3 over x plus 2. So what is the error here is what is meant by subjecting x. When you subject x, there can't be an x here. So here it's wrong because here you have said that x is equal to someone, but even there is x here. So this is wrong. So always keep in mind when you subject someone, in the other side, there can't be that variable. So when you subject x, there can't be any x's here. No any x terms here. So what is the challenge we got here? is that having this x squared and 2x both in the same time. So what is the challenge what is the challenge we got here is we are having this x squared and 2x, this both x squared and x in the same side. So this is wrong. So you have to think of a way, how can I take this x squared and 2x to one place? So that is how we should think or approach a question. You have to think, what is my objective? My objective is to subject x here. So how can you write this x squared and 2x as 1x or in one place? You are thinking that way. So in maths, there's something called completing squares. So when we complete squares, if you can remember, how can we write this x squared plus 2x? That can be written in terms of, if I have x squared, I'm writing x. The coefficient of the middle term is 1, half of that is 2, half of that is 1, x plus 1 squared. So in this one, always keep in mind when we complete squares, this x squared term and the 2x comes as 1x. Comes as 1x. And then what is the additional one? It's minus 1 plus 3. I get y is equal to x plus 1 squared plus 2. Y minus 2 is equal to x plus 1 squared. If you consider the square root of both sides, I get x plus 1 squared square root is equal to y minus 2 square root. This gives me x plus 1 is equal to y minus 2 square root. So x is equal to y minus 2 minus 1. So this is how you subject x. So when we have a quadratic function, in order to subject x, I need to complete squares. So when you write this in this way, there is a square root. So what's your range? If there is a square root, the square root should be greater or equal to 0. So y is greater or equal to 2. So you get y is greater or equal to, this is your range. You can either keep as an inequality or you can use the set notation to keep this. So it's from 2 up to infinity. So this is your range. Clear? Okay, put a red star mark and write in this way, write in a normal pen. Put a red star mark and write in a normal pen. To subject x from a quadratic function, to subject x from a quadratic function, we need to complete squares. We need to complete squares. We need to complete squares. Okay. So then do this if you haven't done this. Don't look at the board. Complete in squares, you can do that alone. The ones who have completed this can now do this one. Find the range of fx is equal to x squared plus 6x plus 17. Find the range of x squared plus 6x plus 17. So always keep in mind when we have a quadratic one, the quadratic expression or function, to subject x there, you have to complete squares. You have to complete squares. What we got here is x squared plus 6x plus 17. X squared plus 6x plus 17. Okay. Okay, so here then how can we subject x here? Same thing. Y is equal to x squared plus 6x plus 17. So when you complete squares, it's x plus 3. So how did 3 come? It's half of 6 is 3. And then we have 3 squared should be taken out, minus 9 plus 17, which gives me y is equal to x plus 3 squared plus 8. So when you take this to this side, it's y minus 8 is equal to x plus 3 squared. Y minus 8 square root is equal to x plus 3 squared, the square root of this. Okay, so then I get x plus 3 is equal to y minus 8 root So x is equal to y minus 8 minus 3. No, not 3, it's, 3, minus 3. So here we got a square root. Since we have a square root, it's y minus 8 should be greater or equal to 0. So my range is y is greater or equal to 8. My range is y is greater or equal to 8. So you can either write using the inequality notation, or else you can write using the set notation. My range. Okay. Okay, so there's another way that you can write the range. Okay, listen this. So I'll tell this example that y is equal to x squared. I'll start from here. So there's another method to write the range. Okay, okay, complete this. I'll give like 1 more minute. Everyone complete them, because I need you to focus this when you do it. Complete this up to here, write the range. Okay. Okay, now look at this. Look at the board. So there is another way that we can write a range. So what is the range? Range means the inequality of y. No? Range, like at the end, we are getting as the range is the inequality of y. So what we consider as the range. Now look at this. So here, what is the normal procedure to find the range? First, we have to subject x. Okay, we have to subject x, and then you have to check for a square root or a denominator. If not, it will be the entire real number set. Okay. So here y is equal to x squared. Now tell me, what can you say about x squared? What can you say about x squared? It's a variable. Okay, it's a variable. So it's squared, no? A squared term is always, it's positive. Can it be 0? Can or can't? It can be 0, because the square of 0 is 0. So here it's clear, x squared is always greater or equal to 0, no? So that you admit. So what is x squared? That is y, no? So y is equal to x squared. So if x squared is always greater or equal to 0, what can you say about y? Y is even equal to greater to 0. So range is an inequality of y, no? The range is the inequality of y. So in this one, it's clear that x squared is always greater or equal to 0. So y, which is x squared, is even equal to or greater to 0. So you can directly write the range even in this way. So even that is acceptable. You can even write the range directly in this way. But there's an additional thing that why I'm asking you to subject x, because of the next topic that we are going to do. It's called inverse function. So that's why I'm asking you to subject x, but you have the right or freedom to even find the range in this way. Okay, now tell me, the function is y equals x squared plus 1. Okay, so if you find the range in the normal way, how did I take the range in the normal way? X squared is equal to y minus 1. So x is equal to y minus 1 square root. Okay, now tell me, if x is equal to y minus 1 square root, what is the range? This should be, talk. If not, it's boring. If you don't talk, it's boring. So what can you say about the square root? It's y minus 1 is equal to greater than 0. So what is my range? My range is, this is greater or equal to 1. That's clear. Okay, now look at this. The other method that what I just discussed. What can you say about x squared that is greater or equal to 0? So that you admit. So what we got is x squared plus 1. No? So what I got is x squared plus 1. So when I add plus 1 to both sides, I get that x squared plus 1 is equal or greater than 1. Because x squared is equal or greater than 0. So when I add plus 1 to both sides, I'm getting x squared plus 1. So what is x squared plus 1? Tell me, what is x squared plus 1? It's y. Clear? What is x squared plus 1? It's y. Okay, then I get that y. So x squared plus 1 is y. I get y is greater or equal to 1. Y is equal or greater to 1. So, but what we want as the range is the existence of y. So that's what we have to find. Clear? You can even find it this way, but this is a normal way. Anyone, if you can do subject in properly, Okay, anyone, if you can do subjecting properly, you can subject and get the answer. But there is another method, I admit, you can even do in this way. Okay, so same thing, I'll do this one. I'll do this example. So I'll do this example. So here we have taken y is equal to x squared plus 6x plus 17. Okay, now look at this. So when you complete squares here, you get that x plus 3 squared is equal to plus 8. So that is what you get. Clear? So that is what you get. Okay, Nidhi. Behind. Okay. Clear? Okay. Can you wake up? Okay. You have to pay attention, nah? Pay attention. And just look at the others, whether they are sleeping. Okay. අර අපි කියන පරාර්ථකාමී මිනිස්සු ලෝකේ ලස්සන කරයි කියලා. So self not selfish, selfless. No. පරාර්ථකාමී selfless. Selfless. Selfless මිනිස්සු selfless people makes the world nice. So you have to just check about who's the surrounding, nah? Whether they are sleeping. You don't let them sleep, huh? Yeah, don't let him sleep. Good. Okay, listen. Here, so okay, silence. So here, wait. Here what I have done here, I have completed squares. And now look at this. I know since x plus 3 squared, this is a square, it's a square. So when we have a square, it's anyways greater or equal to 0. Whatever the square you got, we know in math it's greater or equal to 0. So now if you add 8 to both sides, because here the requirement is adding 8, you add 8 to both sides. So why did I add 8 to both sides? Because here, I know this is y. I know this is y. Okay, now your y is greater or equal to 8. So which answer that I have taken previously? So y is greater or equal to y. Equal to 8. Clear? So you can even find the range in this way. You can directly use this algebra to find this range. So here, it's directly y is greater than 0. In this one, this is the normal method. So this is what I just explained. X squared is greater than 0. So x squared plus 1 is greater than 1. Okay, write in this way. Put a red star mark and write in a normal pen. A red star mark and write in a normal pen. Silence. Can't talk. Okay, right. Do this. The range of a function can be even found. The range of a function can be even found in the following manner. The range of a function can be even found in the following manner. Okay. You then do these examples. You don't have to put a number, just put any number, Q, just write in this way. So you can find the range in this way. Get the help from the board for the first two questions and do the third question alone. Do the third question alone. So it's Q1, Q2, and this is Q3. So after these three, you can find the range of this one using this method. Okay, same method. Y is equal to 2x squared plus 7. Find the range of this one using the same method. Y is equal to 2x squared plus 7. Sorry, minus 7. Find the range of y is equal to x squared minus 7. Okay, so here, how can we do it? It's clear, the same thing. X squared is equal or greater than 0. So even though you multiply by 2, when you multiply 0, it's 0 because there won't be any change when you multiply 0 by 2. So I need 2x squared minus 7. So I'm subtracting 7 from both sides. So here it's minus 7. 0 minus 7 is minus 7. So you can just write it that way, 0 minus 7. So I have subtracted 7 from both sides. So then this is y. And I can get that y is greater or equal to minus 7. So this is what we write as the range. You can write the final answer is a element of minus 7 going up to plus infinity. Clear? Going up to plus infinity. Okay, hands up who got this in this way, that y is greater or equal to minus 7. You got it, no? Okay, good. Then do question 7 first. Wait, do question 7 in a hand below in a rough paper or in the end of your book. Because the additional part that I need to explain before this. Do question number 7. Find the range in a handbill or rough paper, or like the last page. Silence, nothing to talk. Just do it either on a rough paper, handbill, or the last page. A small one that you can find it, but I want you to do not in your book because of a reason. Okay. So when you do this in the normal way, what we get is that y is equal to square root x minus 1. So this is what I get now. So this is what I get. So when you consider the square of both sides, this becomes the square root cancel off. And when you take minus 1 here, it's y squared plus 1 is equal to x. So x is equal to y squared plus 1. So when you write the domain, there is a restriction. So tell me, what is the domain here? What is the domain here? Domain. X is greater or equal to 1. The domain is the inequality of x. So here we have subjected x. No? So after subjecting x, there is no any square root and there is no any denominator. Denominator ekkudna, square root ekkudna. So I told you, when there's no any denominator or no any square root, that means the range becomes the entire, tell me, the range becomes the entire real number set. So here what you have written should be that y is the element of the entire real number set. So what is the reason that you write this? We don't have a denominator and we don't have a square root. Okay, hands up who have subjected x in this way and written this answer. Okay, hands up who subjected this. X is equal. Okay, so there's a additional thing that we need to explain here. Okay, now listen. If I consider the function y equals root x, we call this as a square root function. So same thing, if you subject y squared is equal to x, so simply x is equal to y squared. So here when you square both sides, you get x is equal to y squared. So no any denominators, no any square roots, means y is an element of R, the entire real number set. Okay, now look at this, what happens here. Okay, but here, tell me, what is the domain? What is the domain here? What is the domain? It's all the positive numbers, greater or equal to 0, all the positive numbers. Okay, I need you to answer. I know that you know the answers. But I want you to answer not only the first 2-3 rows, because then only you, like, I feel interactive. Okay, so then even you won't feel boring. Anyways, like, learning is something boring, no? Okay, that we can't avoid, no? But if you like somehow get engaged with me, it's like, then it will be less boring. I don't say that it's not boring at all. So that's why I need to talk. Okay, sometimes I'm asking what is 1 plus 2. I know that you know it's 3. If not, you won't come here, no? 1 plus 2, but I expect you to answer. Even both sides, huh? Both sides. If not, like, I'll be asking separate this column wise, not column wise, this wise, bunch wise. Okay, so I need, like, it's, if not, it's hard, like, because I do the class in an energetic way. So I expect the students to do not be like energetic means not the other energetic, but I need you to be active and engage with me. කතා කරන්න ඕනේ. Should talk. சொல்லுங்க. Okay. Clear? Okay. So here, look at this. Now tell me the class. What is the end? What is this? The domain here. They are all the positive numbers. All the positive numbers is the domain. Okay. So I was explaining. Silence, silence. Now your domain is the entire real. Sorry, is the positive real number set. So it's R plus including 0. But your range, according to the answer that you have taken, your range is the entire real number set. Your range is the, no, listen, entire real number set. Okay, now tell me, during O levels, what did you learn as the answer of root 4? In O levels, you learn that that is equal to plus or minus 2. Clear? So that is how we learn. This is equal to plus or minus 2. So the range is the entire real number set, means any number can be there. No? Okay, now look at this. If you say that we have minus 2 here and plus 2 here, we have minus 1 and plus 1 here, and we have minus 3 and plus 3 here, and this, the domain and the codomain has been connected by the function of y equals root x, which means the square root of 4, we have considered that the square root of 4 is equal to plus or minus 2. Now this is considered to be plus or minus 2. This is considered to be plus or minus 1. This is considered to be plus or minus 3. Clear? So we are talking about functions, and I told you before coming to functions, we discussed about relationships. And I told you only 2 relationships or relations are considered to be functions. So here, according to the example that I took, one son is having 2 fathers. One son is having 2 fathers, which is biologically impossible. That can't happen. So I told you this one-to-many relationship is not a function. I told you that one-to-many relationship is not a function. Because of that reason, if we consider this range, if you consider this entire real number set as the range, then this is not a function. But we're talking about functions, domains, codomains, these all are functions. So because of that reason, in order to make this square root function or the square root a function, what we do here, I restrict my codomain, or I define my codomain to be the positive real number set. So I have taken a restricted codomain. I told you normally as the codomain, we take the entire real number set. But there are special cases we are having restricted codomains. We have limited the codomain. So what I do here is I restrict the codomain only to these positive values, which means this goes away, this goes away, and even this goes away. So if the codomain only consists of positive answers, so these arrows will go away, which means my previous one-to-many relationship, has been converted into a one-to-one relationship. So what did I do? The codomain of a square root function is defined as the positive real number set. Is defined as the positive real number set. Because of that reason, so I know the range is a subset of codomain. Range එක කියන්නේ codomain එක ඇතුලේ ඉන්න කෙනෙක්නේ. So if the codomain is the positive real number set, can the range become the entire real number set? If the codomain is the positive numbers, range is something inside this. So can the range become the entire real number set? So that's not possible. So there is a special case here only in the square root function, only in the square root function, okay? Every other function you have to do in the normal way. But only in the square root function, there is one thing that we define the codomain as the positive real number set. Because of that reason, whatever range we get, just find the range in the normal way. Okay, find the range in the normal way And whatever the range we get, so I'm getting the entire real number set as the range. I'm getting the entire real number set as the range. So whatever the set you get, you have to only consider the positive part of this range. You have to only consider the positive part of this range. So here, the positive part is this part. So I'm only considering that part and I won't be considering this negative side. So even though I get this answer, since a square root function, you can write since a square root function, since a square root function, y is taken as only this positive side. I'll be taking the positive side of the answer that I get. So what is your range? Your range, y is greater or equal to 0. So this is my range. Okay. Normally, because even I have learned this lesson once at school and once at the class that I went. And initially, when I was doing when I started doing whole classes, so I started doing whole classes somewhere around 2020. For the so my first A-level batch was 2022. So when we like, I used to do individual classes after A-level since 2016. I used to do individual classes. So where I go to different homes and do this home visit skill again. So when I started doing mass classes in 2021, I have even watched some of the recordings of different tutors for my learning purpose. For my learning purpose, I admit that I have watched different tutorials of lessons of different tutors who do combined maths, because I wanted to learn how to address a mass class. So it's not like individual class. When we are doing individual class, if a student asks me a question, say how did this come, I can tell him ඕක වැඩක් නැහැ කොහොමත් උත්තරේට හොම කරන්න කියලා. මොනවාරි කියන්න පුළුවන්. But when it comes to a mass class, I can't come here and tell, oh, you don't have to care about that. Just do in this way, you'll be getting the answer. So I can't talk in that way. No? So I needed to, so I have watched few recordings and these online classes of some tutors. But this is one point that I have noticed. Like, I'm not telling that any tutor won't be addressing this one. But out of the tutors that I watched the recordings and I have even learned this lesson once at school and once at my class, this part I have never experienced. I have never learned this from anywhere else. Because some tutors think that this is a complex part. If we are going to explain this, students might not understand that. So that is their logic at this stage. If we try to explain this, the majority of the students might not understand what I'm going to tell. But like I don't like to do in that way, so I try my best to explain in the simplest way. And when we complete a lesson, it should be completed 100%, including every point. Any point can't be kept, cannot be left over. Any point we can't just keep it in that way. So that's why I just wanted to take this. So there's only one limitation I told you. When you are supposed to find the range, you can, for any function, do it in the normal way. Range එක හොයන්න තිබ්බම normal විදිහට කරන්න. So what is the normal way? Can now tell me what is the normal way to find the range? First, you need to subject x and check whether there are denominators or check whether there are square roots and find the range in the normal way. But always keep in mind, if it is a square root function, no matter what answer we get as the range, we have to only consider the positive side of the answer I get. Okay, so whatever the answer you get as the range, you only have to consider the positive side of the range. Clear? So that doesn't mean that every time the range is this. So let's say if you are solving this in a normal way and you are getting the range in this way. So this is your range. So this is your range. So I told you, whatever the range you get, you have to only consider the positive side, which means this side you won't be considering. So what is the range here? Only y is greater or equal to 1. So we'll be only considering the positive side of the range that I get. So this is only for square root functions. This is only for y equals a square root function. Okay. And now come to the book and write in this way. Using a black pen, write note, and in front of that, using a red pen, using a black pen, write note, and then using a red pen, write this. using a red pen, write this. Square root, range of a square root function. 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 Okay, so first do this. Take y equals root x, y equals root x, and x equals y squared, and get that y is an element of the entire real number set. So this is what we take as the range. And then row this one, row these two sets. First row this. So here I have taken that the domain is the only positive number set, silence. And range is the real number set. So that is what we got as the answer. Don't sleep while writing. Huh? You can keep your head if you are having a headache, or like if you're not feeling well, then you can keep your head. If not, like heads up. Okay, so draw these two sets and take this. Okay, so here the domain is R naught plus the positive real number set. Range is the entire real number set. Okay, write in this way. Write in this way. Write in this way. If we consider this range, if we consider this range, it is an one to many relationship. If we consider this range, it is an one to many relationship. It is an one to many relationship. It is an one to many relationship. Okay. The next line, write it this way. Therefore, to make the square root function, therefore to make the square root function a one-to-one relationship, therefore to make the square root function a one-to-one relationship, a one-to-one relationship, write this part using either red pen or black pen. This part, the codomain of a square root function, the codomain of a square root function, the codomain of a square root function is defined, the codomain of a square root function is defined as, write this, r plus naught, is defined as r plus naught, is defined as r plus naught. Therefore, normal pen, therefore, the range should be, therefore, the range should be considered accordingly. Therefore, the range should be considered, the range should be considered accordingly. Okay, then draw this one and show that the codomain is R naught plus. So your new range is not this one. So this is not the range. This is not the range. Your y, this is not the range. Your y is a positive number. So this is your new range. So that's why I told you the range should be selected, considered accordingly. According to your codomain, you have to select the range. So here it's clear, it's a one-to-one relationship. Okay, here it's a one-to-one relation. Silence. Here it's a one-to-one relationship. Okay, then after this one, then write in this way. When finding the range of a square root function, when finding the range of a square root function, when finding the range of a square root function, find it in the normal way. Find it in the normal way. Find it in the normal way. But only the positive side, but only the positive side should be taken as the range. But only the positive side should be taken as the range. Should be taken as the range. Okay. So then do this question number 7 in your book. First initial you get this answer. But I told you in that answer only select the positive side. So this negative side won't be there. The negative side won't be there. Clear? So this side won't be there. So then I can write since a square root function. What is the range? It's only the positive side. So this is my range. And after this, do question number 9 and 10. After this one, do question number 9, 10 and 11. Two questions, 9, 10 and 11. Nine, 10 and 11. So I'm still referring to question number 1. Okay, main question 1. So we did question number 7. Do 9, 10 and 11. Find the range. Find the range. So do 7 normal විදිහට ගන්න. Final answer ke මොකක් වුණත් you have to take the positive side only. So whatever the final answer you get, you have to find the positive side. Do question number 9, 10 and 11. Okay. So question number 7. Okay, so this is y is equal to 1 over x minus 1 square root. We got a square root function. So whenever you have a square root, keep in mind, like at the end, whatever you get for the range, you only have to consider the positive side. Okay, at the beginning, when you have the square root function, you have to make sure that you only consider the square root, the positive side. Okay. Okay, so here, then when you square this, y squared is equal to 1 over x minus 1. So y squared to x minus 1 is equal to 1. So I need to subject x, no? So when you divide by y squared, it's 1 over y squared. X is equal to 1 over y squared plus 1. So this is what I get, no? So normally, how you write the range here is that y can't be equal to 0 because it's in the denominator, no? So y can't be equal to 0. So what is your normal range? Your normal range, you say that y can be any real number excluding 0. So what is the way that you write your normal range, that you are telling that y can be any number but it can't be 0. But I told you, whatever the range we get, so according to this one, you have got the range that y can't be 0 but it can be any number, any real number. Clear? I told you, whatever the answer we get, we only have to consider the positive side. So forget about this side. Forget about this side. What is your new range? Range is y is greater than 0. Not the entire real number set. There's no inequality. So your range is the positive real number set. Clear? So this is your new range. Whatever the answer you get for the final answer, only consider the positive side of it. Only consider the positive side of it. Clear? Okay, then do the next two questions. If you haven't done this, do the next one properly. Do question number 10. The main thing here is we need to subject x properly and then write the final answer. Okay, so same thing in the second one. Y is equal to 2 over x plus 2 square root. So now when you square this, you get y squared is equal to 2 squared is 4 over x plus 2. So y squared into x plus 2 is equal to 4. I need to subject x. So x plus 2 is equal to 4y squared, which means x is equal to 4 over y squared minus 2. So I have subjected x here. Now according to the normal way, the only thing that I get is y can't be equal to 0. Y can't be equal to 0. So what is the normal range we write that y can be any real number but it can't be 0. But I told you this is wrong because we only have to consider the positive side. So we have get the entire real number set excluding 0. But take out this real negative side. So there's no any negative side. So what is my final answer? My new range is the positive number set, real number set of y is greater than 0. Not equal. Y is greater or equal to 0. Okay, hands up who have subjected x properly in question number 10 and taken this answer. Okay, good. Then do question number 12. Silence, do. 11 ඉවර 11. Hands up who's finished question number 11. Okay, good. So there are still, no, question number 11. Okay, now look at this, silence. So fx is equal to 9 minus x squared square root. So first thing, we need to subject x, no. So when you subject x, I square both sides, so I get y squared is equal to 9 minus x squared, not x, huh? So when you take x here and take y there, x squared is equal to 9 minus y squared. X squared square root is equal to 9 minus y squared square root. So x is equal to 9 minus y squared. So I'm getting this, no? So I'm getting a square root. Okay. So you can't write this as 3 minus y, okay? Because we have discussed about square root simplifications. You can't write this in this way. Because the square root of 9 is equal to 3, okay, I admit. Square root of y squared is equal to y. That even I admit. But did we learn something that a squared plus b squared square root is equal to a plus b? Did we learn something like that? You can write this in this way. If we have not a squared plus b squared, if we have the total square of a plus b squared. Inside the square root, if we have a plus b the square root, then this is equal to this. But separately, if we have a squared plus b squared, you can't, this is not equal to a plus b, okay? Because these type of simplification mistakes normally you do. Because I know, like, even though I don't ask, some students might have write 9 as 3, y squared as y. That is wrong. You can't write in that way. So we have a square root function. So we have a square root function. So we have a square root function. So when we have a square root function, what is inside the square root should be positive. 9 minus y square should be greater or equal to 0. So don't do that mistake that you did last week. Okay, එක පැත්තකට දාලා square root එක ගත්තද නෑනේ. You didn't write it that way, no. The mistake you have done last week. So what did you do here? You put y to the other side and consider the square root to get that 3 is greater than y. කරන්න වැරදි එකම වැරද්ද දෙපාරක් කරන්න එපා. It's okay to do like mistakes, but don't repeat that mistake. If you have done this, this is wrong. Huh? You have to use the sine curve method. You have to use the sine curve method. So this is 3 squared minus, first factorize. 3 minus y, 3 plus y is greater or equal to 0. And when you consider number line, this becomes 0 in minus 5, this becomes 0 in 3. And if you think of a number in this range like minus 4, this is 3 minus minus is plus, but this is minus, so it's minus. If you think about something like 1, 2, even this is plus, even this is plus. Think about something in this range. If you go with 5, 6, this is minus, but this is plus, so it's plus. So here, if we were supposed to find the range in the normal function, what you write as the range is this. So this is what I write as the range. But I told you, you can't admit this one. So it's clear like normally we write this in this way. But that is wrong because in the square root function, if it is a square root function, I can only consider, so you can't consider this entire minus 3 to plus 3. I can only consider the positive side. So this is what I get as the answer. But always keep in mind, you have to take out this negative side. You have to take out this negative side. So what is your range? Your range should be between 0 and 3. So I admit you are getting an intermediate answer of this. That's okay. But always keep in mind, for the range, you have to only take the positive side. So what is my range? Y is greater than 0, but it's less than 3. Y is greater or equal to 0, but it's less than 3. So this is my range. Okay, hands up who have taken this range. Okay, so hands up again who have taken this range. Okay, never mind. So then do this and find the range of fx equals 25 minus x squared square root. Find the range of 25 minus x squared square root. Silence. කතා කරන්න බා. උත්තර අරගෙනත් නැහැ. Like 20 students or 20, 30 have taken the correct answer. So focus and do it alone. So whatever the answer you get for the range, you only have to consider the positive side. Okay, so you only have to consider the positive side. So this is an intermediate answer like we get for the range that it is between minus 3 and 3. So I told you if it is a normal function, this is okay. If this is a normal function, then this is okay. But since it's a square root function, you only have to select the positive side. So always keep that in mind. Whenever you see a square root function, you know that you will be only considering the positive side as the range. Okay, so what is the question that I gave? Find the range of fx equals 25 minus x squared. Silence. Y is equal to 25 minus x squared. First you need to subject x. So y squared is equal to 25 minus x squared. X squared is equal to 25 minus y squared. So x is equal to 25 minus y squared square root. So what you have inside the square root should be positive. Should be positive. So it's the difference of two squares. 5 minus y and 5 plus y. So if you consider the number line, same as the before one, this part it is minus. This part it is plus and this one it is minus. But I told you that, so this is what I get as the answer. So here you can directly write it, but even though I get this entire one, so this is the intermediate answer that it is greater than minus 5 and less than 5. But I told you that can't be considered as the final answer since we only consider the positive number set. So this is what I normally get. So take out this one. So take out that part. So what is your range? It's in between 0 and 5. So what is your range? It's in between 0 and 5. Your range is in between 0 and 5. Okay, hands up. Who got this answer? Same thing. Okay, same drill. So I'll keep this in mind. Okay, silence. Okay, this side, tell me. Okay. This side, how to find the domain of a function? How to find the domain of function? We have to find the range of x. No. For that one, we have to check whether there is a denominator, or else this side there is a square root. If there is a denominator, we have to take out the values that make the denominator 0. If it is a square root, you have to consider that what is inside the square root should be positive. If there is no any square root and no any denominator, no any square root and no any denominator, then what can you say about the domain? The entire real number set will be the domain. Same thing, same flow when you find in the range. One additional step, first you need to subject x. First you need to subject x. And then look for square roots and look for denominators and go with the same drill. But I told you just one thing, only in one function when we have y equals a square root. If it is a square root function, find the range in the normal way, but whatever the range you get as the final answer, only consider the positive sign. Clear? Okay, so this is like the main thing. So we only have that one additional thing, the inverse function. So defined in the domain, range, and codomain is something, a small thing. Okay, I'll give you like 1 minute, drink some water. Then we kata karana today. Okay, okay, write the topic. Okay, silence. Okay, write the topic, inverse functions. Write the topic, inverse functions. Okay. Okay, silence. No, listen. So inverse functions is the next main thing, but there's only one additional part that we have to explain here. So inverse function is something like this. Now, let's say we are having a independent variable x and we are having the dependent variable or the image y. So the mathematical rule that connects x to y is called as the function. So I told you what is a function. Function is the mathematical rule that connects x to y. So inverse function is having the same meaning like reverse. So what we call as reverse is going back. No, reverse is going back. So inside this word reverse, we have the meaning that going back. But because I think mentioned that before, even though inside the word reverse we have the meaning going back, people use pitipassata reverse karano. Okay, so but reverse has the meaning that it is going back. So we use the word pitipassata reverse karano. And return, inside the word return, we have the meaning that we are giving it back. But we use mang pota gatta mang apau return karanna. So apau return karanna. Same with catch allana. So we use that no in the interval මොනවද කරන්නේ අද ක්‍රිකට් ගහන්න බෑ අපේ කාලේ සම්බෝල කොටනවා කියලා තිබ්බ මම දන්නේ දැන් එහෙම කරනවද කියලා සම්බෝල කොටනවා means like we use this දැන් කරන්නද එහෙම අර ගන්න දෙරේ අර පොඩ්ඩක් අර පොඩ humidity පැත්ත හිතුවොත් මේ වම් අතින් සම්බෝල කොටන්න කියලා. එතකොට වමෙන් අනිත් පැත්තට shape නේ වැඩි පව එකෙන් ගහන්න බෑ ඒ වගේ කියලා අර එහෙම දෙරේ අර කියන ඉන්ටර්වල් එක කියන අපි catch අල්ලමු කියලා ඉස්සර පොඩ්ඩක් මේක ඇතුළේ මම දන්නයිද මම දැන් ළමයි ඒව කරනවද දන්නේ නැහැ. අපි අර තිබ්බ දෙපැත්ත බෙදලා අර බෝලේ පාස් කරනවා and you have to take the catch. ඒක දින තනි අතින් ඇල්ලුවොත් 20යි අත් දෙකෙන් ඇල්ලුවොත් 10යි ඔහොම පොඩි මේවා පොඩි ආතල් ටිකක් තිබ්බා. දැන් ඒව නැහනේ. හරි. එතකොට okay at the silence. So okay, no wait. So I was talking about the word reverse. So inverse function is like the reverse. So what is the inverse function? Is the opposite mathematical operation of a function. The opposite of a function is called as the inverse function. If I say that the function is multiplying by 2, what is the mathematical opposite of multiplying by 2? It's dividing by 2. If the function adds 1 to the variable plus 1, what is the mathematical opposite of plus 1? It's minus 1. So what is meant by the inverse function? Inverse function is doing the opposite of the mathematical operation done by the function. So if the function multiplies by 2, the inverse divides by 2. If the function adds 1, the inverse subtracts 1. If the function squares someone, it consider the square of someone, then the inverse will consider the, tell me, if the function square someone, square karno, then the inverse will square root it, consider the square root. So what is meant by the inverse function? The function that does the opposite mathematical operation of a function is the inverse function. So a function connects x to y, the inverse function connects y to x. The inverse function connects y to x. The function connects x to y and the inverse function connects y to x. Clear? Okay, so the topic is inverse function. Write in this way. The opposite of the mathematical operation, the opposite of the mathematical operation, the opposite of the mathematical operation done by a function, the opposite of a mathematical function done by a function, the opposite of the mathematical operation done by a function is considered as write in a red pen, inverse function is considered as the inverse function. Okay, next line. A function connects x to y. A function connects x to y. A function connects x to y. The inverse function connects y to x. The inverse function connects y to x. Okay, then draw this diagram where we have the function and this is the inverse function. This is the inverse function. Silence. Put it there. Do we don't just draw this small thing? So function goes from x to y and then an inverse function comes from y to x. Okay, write the topic existence of an inverse function. Write the topic existence of a inverse function. Existence of a inverse function. Okay, so I'm not sure whether this is C O S. You can write it existence of a inverse. It's C. Existence of a inverse function. Okay. So now this is what we are going to discuss. A small thing, a theory part. Put it there. Now tell me, a function can be only there can be only two relationships. It's if it is a function. One is it can be either 1 to 1, or the other one it can be many to 1. So if it is a function, it can be only either 1 to 1 or many to 1. Okay, now if I consider this 1 to 1 function, so we have a few x terms here and we have y terms. So when we consider the 1 to 1 function, it's in this way. And I told you the inverse is connecting y to x, no? So here, x to y is 1 to 1. So it's clear. So if I consider the inverse, you can say when you come from this side to here, it's even 1 to 1, no? So when you start from here and come to this side, it's even 1 to 1, no? So it's clear. So when we have a 1 to 1 function, the function is 1 to 1 and even the inverse function is also, the inverse function is also 1 to 1. But now, if I consider a many to 1 function, if I consider a many to 1 function, the function is many to 1, which we consider as a function. But if you consider the inverse, tell me what can you say about the inverse? It becomes a one to many relationship. So if you consider the inverse of a many to one function, it becomes a one to many, which means one to many is not a function. We don't consider. Keep the phone silence, okay? I can't repeat it. Okay. So when we consider when we consider this many to one function, the inverse of a many to one function, the inverse of a many to one function, it's one to many. Because of that, we say out of the two functions, a one to one function, there is an inverse function. The inverse function exists. Inverse function exists. But if it is a many to one function, there is no any inverse function. The inverse function of a many to one function does not exist. It doesn't exist. So the topic is existence of a inverse function. A function can be either one to one or many to one, but out of these two, there will be an inverse function only if it is one to one. Because if it is many to one, the inverse will become one to many, which is not considered to be a function. So there is no any inverse function. Clear? Okay, so as a summary, I can say only a one to one function will have a inverse function. Only a one to one function will have a inverse function. Okay, write it this way. Write it this way. A function can be either a function can be either one to one, can be either one to one or many to one. A function can be either one to one or many to one. Let's consider these two instances. Let's consider these two instances. Okay, then draw this one and here write that the inverse function exists. But here the inverse function doesn't exist. Okay, so here inverse function exists, inverse function doesn't exist. So what we can summarize here is that a one-to-one function only will have an inverse function. This one, there's no any inverse function. So that is the theory part. You won't be asking these questions because you won't be asking MCQs for maths, no? Okay, so if you ask MCQs for maths, you can give a question like this way in functions. Select the wrong answer out of the following 4 MCQs. In O levels, there were 4 answers, but in A levels, there are 5 answers. For chemistry and physics, you got 5 answers, not answers. 5 options, and 1 will be the correct one. Okay, so let's, like, if I give a MCQ, select the wrong sentence out of the following. The first one is the range is a subset of the codomain. Correct or wrong? The range is a subset of the codomain. Not sure. Is it correct? The range is a subset of the codomain. It's correct. It's inside the codomain. The second one is normally the codomain is considered as the entire real number set. Normally the codomain is considered as the entire real number set. We did this like last week and today. Yeah. So it's correct, but there are some like customized codomains වගේ ඒවා තියෙනවා හරිද? For example, square root function, it is having a customized square codomain. Only the customized means a specific one, specialized one. So that is correct. So number 3 is a many to one relationship is a function. Many to one relationship is a function. Is it a function? Many to one? Yes, it is a function. Mamboda sarakalawa no. Okay, so many to one is a function. If I ask a question like the many to one function, a many to one function has an inverse function. Is it correct? No, it's wrong because the inverse functions will be only one to one functions. So like we won't be asking these kind of theory questions, but this is good because I told you this one and I told you even last week after A levels, even after A levels, normally after O levels, what you first do is you take out all the books, no? Okay, you take out all the books. කවුරුහරි ළඟ පාත නංගිල මල්ල ඉන්නවා නම් එන්න ගන්න මේ පොත් ටික කියලා you distribute all the books, past paper books and every book you distribute. No? So in A levels even you do that. Unless you do a second shy, you do that. Even though you take 3 years or not, even though you fail the exam, you will be given the books. නංගි ගන්න මේ මල්ලි මේක ගන්න you will be given the books. But it's okay to give any book, but make sure keep the functions note, okay? You can give any book in A levels, but make sure to keep the functions note because I don't want you to go to universities and then asking me, sir, can I get a functions note? Because these days, students who went to the universities in 2022 and 23 A levels, they are like every time asking, sir, can I get a function notes? Because in every, like if you are doing a degree related to maths, engineering, computer science, software engineering, in those areas, these functions will be there. Will be there. And finding the range, finding the domain will be even questions that you get for a first and second semesters in the universities. So always keep in mind, you can give anything after A levels. Okay, you can even give one of the kidneys, that is even okay. But make sure to keep your functions note. Don't give that. Okay, make sure to keep that. Keep your functions note. Okay, then how we are going to find the inverse function? That's really easy. Okay, silence. I'm the only one talking here, okay? So how to find the inverse function? So this is the easiest part of inverse function. So how we find the inverse function is in this way. Now let's say I'm using that y is equal to fx. Wait, I'll give it. So how do we denote an inverse function? If the function is fx, the inverse is denoted by f inverse x. So this is a minus 1, but it is not the minus 1 power. It is minus 1, I admit, but it is not the power. Why do I say that it is not the power? Tell me, if I have a to the power minus 1, how can you write this? How can you write this? 1 over a. But this inverse function f inverse x, this one, you can't write, it is not 1 over fx, okay? It is not the minus 1 power. It is not the minus 1 power. This is just a notation, the way that we denote the inverse function. So an inverse function is denoted by f inverse x. Okay, so after this one existence, write in this way. The inverse function of fx, the inverse function of fx is denoted by the inverse function of fx is denoted by f inverse x. Is denoted by f inverse x. Okay, f inverse x. Then write these two, and towards the right hand side, even note down this because you might do a mistake in that way. So don't. It's not equal. Don't write it is equal. Fx is the function, f inverse x is the inverse function. Okay. Okay, so this is how you find the inverse function. Listen, okay. So this is how you find the inverse function. Now let's say I'm having y equals fx. And if I'm supposed to find the inverse function, I need to find f inverse x. If fx ki inverse එක හොයන්න තිබ්බොත් හොයන්න ඕනේ f inverse x. If I want to find the inverse of fx, I should find f inverse x. So here what I do is I consider the inverse of both sides. I consider the inverse of both sides. So now here it's clear it is f inverse y that I admit. Okay, now I want you to think about this f inverse fx. Okay. Now look at this. So I told you an inverse function is the opposite of a function. So if the function is multiplied by 2, keep your hands over Jack, stay properly. Sorry, sit properly. Don't just lie on that. Like in the PVR, like it automatically goes when you just go and just when you keep your back, you automatically go in that way. So this is not PVR. No, those are sleepy positions. So when you stay in that way, when you are sleepy, and then you're looking at the world in this way. So even then you make me feel sleepy. Clear? Getting in on, yeah? Okay. So I told you, now tell me, if the function is multiplied by 2, what is the inverse? If the function is multiplied by 2, what is the inverse? It's divided by 2. Okay, now let's say I'm having x. Now I'm having x. Now I need you to answer. I'm having x. I'm multiplying x by 2. I'm multiplying x by 2. I'm multiplying x by 2. Okay, what do I get? What do I get? 12? 2x. Okay, so I get 2x. And now I'm asking from this side. So what is the opposite of multiplying by 2? I'm dividing by 2. So what do I get? If I divide that 2x by 2, I get again x. So once again, let's do another one. I'm having x. I'm adding 2. I'm adding 1. I'm adding 1 to that variable. I'm having x and I'm adding 1. So what do I get when I add 1 to x? What do I get? X plus 1. So what is the opposite of plus 1? No, adding by 1 is subtracting 1. So now I have added 1. Now I'm subtracting 1. So when I come back, what do I get? It's x plus 1 minus 1. Again I get x. So it's clear. When you send this x through the function and when you take it back along this inverse function, at the end we come to the place where we started. X became 2x, again it becomes x. X becomes x plus 1, again it becomes x, which means f inverse fx. And now tell me, f inverse fx, first it multiplies by 2, then it divides by 2. First plus 1 is added, and then 1 is subtracted. 1 is subtracted, which means f inverse fx, this f inverse and f2 cancel off, and what is the answer here? It's x. Clear? So I wanted to give you the idea that f inverse fx, f inverse and f cancel off to give me that it is x. Okay, then I have that x is equal to f inverse y. So this is what I'll be using to find the inverse function. Now I want you to find the inverse function. So this is what I'll be using to find the inverse function. This is what I'll be using to find the inverse function. X is equal to f inverse y. Okay. So why did I mention that this is what I use to find the inverse? Okay, look in this way. My function is x plus 1. Y is equal to x plus 1. So what I want to do here is I need you to subject x. So when you subject x is equal to y minus 1. I need you to subject x. So when you subject x, what do you get? You get f inverse y, no? Because x is equal to f inverse y. So when you subject x here, what we have got is that f inverse y, because x is equal to f inverse y. Ix is equal to f inverse y. So when you subject x, I have taken that f inverse y. I have got that f inverse y is equal to y minus 1. I'm going to find the inverse. So I'm going to find the inverse. So we have fx is equal to this. What did I ask you to do? Just subject x. So when you subject x, according to that one, it's equal to f inverse y. Okay, so I have taken that f inverse y is equal to y minus 1. I have taken that f inverse y is equal to y minus 1. Now you tell me, what is the inverse function of fx? What is the inverse function of fx? It's no, not about this, just in general. Fx, what is the inverse function? F inverse? F inverse? Can't hear. What is the inverse function? F inverse? X. So the inverse of fx is f inverse x. But what we have got is f inverse y. But I want to find f inverse x. So here it's the easiest part. What I do here, I just change the variable. Here I just change the variable because if f inverse y is equal to y minus 1, tell me what is f inverse x. What is f inverse x? That is x minus 1. So I get the inverse function. I get the inverse function f inverse x. It's equal to x minus 1. So that's why I told you if the function is adding 1, the inverse will be subtracting 1. The inverse will be subtracting 1. Okay, let's do another example. Fx is equal to 2. 2 times x multiplied by 2. So what I ask you is to subject x. So when you subject x, you get y over 2. But I know when I subject x, what do I get? It's f inverse y. F inverse y is equal to y over 2. But the inverse of fx is f inverse x. So I'm changing y into x. It's just a variable change. So f inverse x is equal to x over 2. So this is my inverse function. So this is how you find the inverse function. That's why I told you I prefer if you find the range by subjecting x. Because after subjecting x, you can even tell the range and you can directly write the inverse function. So when you subject x, there are two things that you can do. You can find the range and you can even write, okay, this is the inverse function. Okay. Okay. First do this one. So we have taken that. Right, just write this one, y equals fx, and come up to this one, x is equal to f inverse y. X is equal to f inverse y. So this lesson is easy, but it's a bit like bulky with theory. There are a few theory parts, but the lesson is easy. You only have to consider about finding the domain, codomain if they ask in, range, inverse, and one more thing, a small part. That's all. You don't have to consider about any other theories. What is the domain? What is the range? Those won't be asked. Only consider after this about finding the domain, range, especially, and the inverse functions. Okay, so come up to here, y equals fx. And then f inverse has been considered. So here I wanted to emphasize that f inverse, the impact of these two cancel off. What have done by f will be taken out by f inverse. What have done by f will be taken out by f inverse. Okay, so here put a arrow in a red pen and write in a normal pen. Put an arrow in a red pen and write in a normal pen. This will be used. This will be used. This one will be used to find the inverse function. This will be used to find the inverse function. This will be used to find the inverse function. Okay, so what we have to do first, subject x, and that is f inverse y, then it is a variable change. Okay, then do these two examples. Do these two examples. Small thing, huh? Don't copy paste the board, do it alone. Do the subject in part alone. Don't look at the board, just do the subject in part. And after when you subject x, that's f inverse y. So if you have subjected x properly, that is f inverse y. That is f inverse y. First then subject x, then you get f inverse y, then the final one is just change in the variable. You have changed the variable y to x, because normally the inverse of fx is f inverse x. The inverse of fx is f inverse x, not f inverse y. It's not f inverse y. Okay, do all the 5 questions on the question number 2. Main question number 2, do all the 5 questions. Find the inverse functions. Silence, silence. Do all the 5 questions in question number 5. Okay, so first one is 3x. Silence, silence. So fx is 3x minus 5. First subject x, so you get y plus 5 is equal to 3x. So x is equal to y plus 5. So I told you when you, divided by 3. So when you subject x, you get f inverse y, which is y plus 5 over 3, but you need to find f inverse x. So change your variable y into x. So f inverse x becomes, it becomes x plus 5 over 3. Clear? So always look at this now. When you say this, the function is multiplied by 3 and 5 is subtracted. Multiplied by 3 and 5 is subtracted. So what the inverse has done is they have added that subtracted 5, and to take out multiplied by 3 they have divided by 3. So every time this is the reverse of this. Subtracted 5, they have added that, and then they have divided by 3 because I have multiplied by 3. Okay, so then you so the next one, so question number 2, the function, I'll just directly write the answer. Fx is equal to x squared. The inverse will become root x. So it's the opposite of this one. You can do it alone. So even this one, fx is x squared minus 1. First part you have to do, you have to subject x here. You have to subject x. So y is equal to x squared minus 1. X squared is equal to y plus 1. So x is equal to y plus 1 root. So that is f inverse y is equal to y plus 1 root. So change the variable, silence. F inverse x. Silence. Can't talk. While I'm talking, can't talk. Don't discuss. Don't talk anything when I'm talking from the mic. Making komat meva. Okay. So then question number 4 is the square root. So here it's clear. What does the function does? Consider the square and 1 is subtracted. Considering the square and 1 is subtracted. So I have added that subtracted 1, and to take out the square thing, I have considered the square root. So every time it's the reverse. And then you have 1 is added, and then you have squared it. 1 is added, and then you have squared it. So when you consider the root, it's x plus 1, which means x is equal to root y minus 1. F inverse y is root y minus 1. Change the variable, which means f inverse x is equal to root x minus 1. 1 is added and the square has been considered. I have subtracted that added 1, and then I have considered the square root and subtracted the added 1. Consider the square root and subtracted the added 1. Last one is y equals x plus 1, and this is called the cubic root, 1 over 3. So square root is 1 over 2 and x minus 1. This is the cubic root. So if we have a square root, to take out the square root, we square both sides. No? To take out the square root, we square both sides. So how can we take out the cubic root? We have to consider the cube. No, to take out the cubic root, I consider the cube of both sides. So how does this cubic root and cube cancel off? We know the power of a power that multiplies. The power of a, not the power of a common man, the power of a power, it cancel off. So y cube is equal to x minus 1 means x is equal to y cube plus 1. So this is f inverse y is y cube plus 1. Change the variable. Y changes to x, which means I have f inverse x is equal to x cube plus 1. Clear? F inverse x is equal to x cube plus 1. Okay, hands up who have taken all the 5 correct answers. Where do we have this power of a common man in KGF? No? Don't underestimate the power of a common. Chennai Express. Okay, query. Okay, so take interval and come by 540. 540. Okay. Okay, write the topic. Silence. Write the topic. Substitute. Okay. Silence. Substitution of values. Write this. Substitution of values. Silence. Substitution of values to a function. In a function, sorry. Substitution of values in a function. Substitution of values in a function. Okay. Okay, so I told you when we have this function fx, so let's say it's equal to x plus 1. So what is the function that fx is equal to x plus 1? So what is the meaning of a function? It combines this independent variable with the dependent variable. So what happens here? Whatever we have as the independent variable plus 1 is added to that function. So that is the meaning of a function. So whatever we have here plus 1 is added to that function. Okay, plus 1 is added. So now let's say that this variable has been replaced by fa. That means even this x should be replaced by a. So it's a plus 1. So that's why I told you, whatever we have as the independent variable, here plus 1 or 1 is added. So if it is fa, that is a plus 1. If it is, let's say fb, that is b plus 1. So whatever we have here, so here x has been replaced by a. That means even this x should be replaced by a. Here x has been replaced by b. That means even this x should be replaced by b. Okay, if you understood this properly, now tell me, if we have fx squared, okay, fx is equal to x plus 1, then tell me what is fx squared? What is fx squared? So here x has been replaced by x squared, no. So even this x should be replaced by x squared. So this is not x plus 1 squared, okay, not x plus 1 squared. Here when we replace it, it's x squared plus 1. So whatever you got here, it's that variable plus 1. Okay, now let's say I'm having something like f1 over x. f1 over x. Now tell me, f1 over x, it's equal to what? It's 1 over x, we have plus 1. Clear? Okay, if I have something like x plus 1, x plus 1, x over x plus 1. So what is inside here? It's x over x plus 1. Okay, then this is equal to x over x plus 1 plus 1. You can simplify it if you want, but here what I want you to understand is whatever we have replaced this x by any term or variable or anything, that one should be even replaced here. So that is what we consider substitution of values in a function. Okay, now let's say gx is equal to x over, now you need to tell this properly, x square plus 1. So here it's the function. Gx is equal to x over x square plus 1. So here we got x and here we got x squared plus 1. Is it clear? Okay, now tell me what is GA? What is GA? It's A over A squared plus 1. What is GB? It's B over B squared plus 1. Okay, now tell me, if I ask you what is GX squared, it's simple. Even this variable should be replaced by x squared, even this one should be replaced by x squared. So when we have gx squared, when you replace this by x squared, here we have x squared. But tell me, here when we have x, it's x squared. No. Here it's x squared. A, it's a squared. B, it's b squared. Then tell me, if we have x squared, what should be here? The square of square, x squared, has been squared plus 1. So if you want, you can simplify it, x squared over x to the power 4 plus 1. Okay, last one. Then tell me, what is g1 over x? What is g1 over x? Let's write it here. What is g1 over x? What is this? It's 1 over x over. So here x should be replaced by 1 over x. 1 over x over. Here what we got? 1 over x squared plus 1. So here it's 1 over x squared plus 1. So when you simplify this, so you can simplify. Even here you can simplify. Even these I didn't simplify, but you can simplify. If they are asking to simplify, you have to simplify. Okay. So here if you simplify this, you get the answer 1 over x. So here I'll write it. It's 1 over. No. It's 1 over x squared. No. So you can simplify in this way. You can take x squared as the listen. You can take x squared as the common denominator here. So it's 1 plus x squared. And we have done these type of simplifications in basic math. So x squared and x cancel off. X is remain in here. That goes to the numerator. X and x squared cancel off. X is remaining. So what is g1 over x? It's x over 1 plus x squared. It's x over 1 plus x squared. Somehow we are coming to the same thing. So here according to this simplification, we come to the same place. That is okay, but that is g1 over x. So what I want you to understand is when we have replaced the variable, every x should be replaced that variable. Here has been replaced by b, by x squared, by 1 over x. Clear? So here this we will be using for the next part, last part of functions that we will be doing. You need to have a clear understanding how to replace a variable in a function. Okay, write in this way. Write in this way. So let's simplify that later. For now, I'll just write in this way. Write in this way. When the variable of a function, when the variable of a function has been replaced every independent variable in the function, every independent variable in the function should be replaced in the similar way. Should be replaced in the similar way. Should be replaced in the similar way. Clear? Okay. So this is, so copy down these two. So when here we have x, whatever has been replaced by x, as replaced as x, you have to change that even this x get replaced. So when you change x here, not only this x, even this x and this one should be replaced. All these x should be replaced. Okay, copy down these two. So then we can do the last part of the lesson. Okay. So So again, I'm telling you, whatever you have written here, it should be replaced in every x. Okay, here it's clear. We have 2x. We have x in two places. So when you replace this, it should become here and even it should be come in here. Clear? Okay, then write the last topic of the lesson, composite functions. Write the topic, composite functions within brackets, function of a function. Composite functions within brackets, function of a function. Okay, so silence. So what is the meaning of a function or composite function? Is normally that what we have inside this function is a variable. It's an independent variable. Okay, so listen. Try the topic, composite functions. Okay, function of a function. Okay, now look at the board, everyone. Okay, stop other work. Okay, so normally when we have a function, inside the function we have an independent variable. But here you can see even in the name, it's function of a function. So what do we term as the function of a function or composite function? If we have a function inside another function. So previously it was only like fx. Simply it's an independent variable. But now I have a function inside this main function. So what is inside gx? So what is inside fx? It's gx. So the independent variable of the function is even a function. The independent variable of a function is even a function. So this is what we term as a composite function or function of a function. So even this is the same f g fx. And there might be three functions like we have fx, and then we have g. Inside g we got fx, and even we can take another function like f. So we have fx, inside it like inside g we have fx, and inside f we have this g fx. So it can be written in this way. So another one, we can have a g, inside we are having another g, and then we are having a fx. So when we have a function inside another function, we call it as a composite function or function of a function. So here the independent variable is a function. It's not a variable, it's not x, it's another function. So there's a notation that how we denote this. So normally this one fgx is denoted as f naught g. This is not O, this is f naught g. So you have to use the same order, f naught g. So this is g naught f. Same order. So this is f g f. So it's f naught g naught f. The notation of a composite function. So here it's g naught f. Clear? It's g naught f. Focus. Bahang ඉන්නේ ඉතින් අපරාධ 5000 ගෙවල් එන්නේ ඉගෙන ගන්න. අපරාධනේ. ගෙවන්න ඕනේ නැහැ. ගෙන්නතු ඉන්න එහෙනම්. ඇවිල්ලා ආවන ඉගෙන ගන්න. I can see like it's like 1 2 3 bumblebee. When I look at the board, look at this. And then doing something. කතා කරන. They're laughing. And when you're laughing, when I look at the board, they stop in the exact position. What is this? You are paying 5,000 and come in here to just enjoy with your friends. So think about the money. These are not free classes, no. Take it serious. You're spending, you're wasting your like parents' money. You're not earning yourself and come in here. No? Why do you just like pay 5,000 and come here to enjoy with your friends? You can go with someone. If you can have 3 friends, it's 15,000. And you can enjoy like an entire month. No, with your friends you can go like 4 days. You can go. I won't be caring about students who are not coming to the classroom. No. So I only care about students who are coming to the classroom, who are inside the classroom. If a parent complain me that he has been coming for classes from home but he hasn't come to the class, then it is one of my matters. If not, like I don't even do. I don't even care. So, but if you come to inside these doors, if you are in the classroom, then it is a matter of me. Aparade. Think about that money. So I'm even giving you a suggestion. If you're having 3 friends who want to enjoy, 3 friends, you don't have to come classes. You can collect 15,000. Good money. No, එකාලේ 15,000 කියන්නේ මොඳ ගානනේ. Oh yes, you got 15,000. Then you can go for all the 4 weeks and you can spend like full in the පුළුවන් chill එකේ. Why do you come here to just enjoy, to talk, to do 1, 2, 3 bumblebee? Those are the things that you have been missed during your childhood. So you can't do everything that you have missed during your childhood. You can't repeat everything when you come for A levels. පොඩි කාලේ කරන්න බැරි වෙච්ච හැමදේම දැන් කරන්න බෑ. කරන්න බෑ. You have to be practical now. So don't play 1, 2, 3 bumblebee here. Because I'm used with those. And it's very weird. I can't understand, like, he's laughing. When I look, he get freeze. So if you think about your jaw's motion, like the position when you freeze. Take it serious. Or else you can go for a commerce class. You can change your stream. The workload is really low. Like you don't have to work that much. Chill like in the antim masa paha you can study hard and get 3 A passes. You can do that. Still you have time. You just started A levels. You have more than like 2 years even. But if you have decided to do maths, you have to do that commitment. Okay. Without commitment, you can't do anything. Without commitment, you can't do anything. Even look at the Sri Lankan cricket team. Only one committed player in the entire team, and he is the only one who's performing. Pathum Nishanka. And like Kamindu Mendis, we can even say he is performing in test match. Others are even not, they are just playing this for like fun. No? They are not committed. No? I saw like today, ICC has updated a post. ICC, the official FB page of ICC has uploaded a post mentioning the highest 5 averages in the test matches they are playing. It's a world test championship. No? So out of so far, who's having the best test average? The 5 batsmen. And there is a requirement minimum of 1,000 runs. And the first one was Kamindu Mendis from Sri Lanka. He has an average of 62.7. Okay. But initially, ICC has made a mistake. They have uploaded that post mentioning Kusal Mendis as first. And then they have even put his photo in the post. So it was a mistake. Mistake done by ICC. Like instead of Kamindu Mendis, they have mentioned that number 1 is Kusal Mendis and then Kane Williamson and 3 Englishmen. So they have made a mistake. So mistakes are okay because Kusal Mendis, Kamindu Mendis, Kaurukatat K Mendis ne antimata. So it's okay. No? But if I'm a cricketer, I know about my average. No? If you are a sportsman, let's say you are a sportsman, you are a football player. Normally you have a rough idea about how many goals that you have scored. When I was playing football, I still play football, but when I was playing football at school, I still have I can remember the number of penalties that I have saved because I was a goalkeeper. I can't score goals unless I score own goals. So I still remember like how many penalties that I have saved. So if you're a sportsman, you have that commitment. So a cricketer knows his average. No? So a mistake done by the ICC page, that is okay. That is acceptable. No? And Kusal Mendis has shared that post. Kusal Mendis has shared that post. And then ICC had corrected one and then he has taken down. But he can give excuse, that is not me, that is my admin. But I don't guess that he is admin. Even admin, if admin is doing, doesn't his admin know that his average? So then he's not admin. So what, like how can he be an admin if his admin doesn't know this, the average of my boss? Okay, so that is the commitment. They even don't know about the average. ICC is doing a mistake, that is totally okay. And then there's this page, Crick Bio or something. They have just put the post in a sarcastic way. Kamindu Mendis did the homework, Kusal Mendis got marks. So they have put that in a sarcastic way. So that is what happens when you don't have the commitment. Okay, whenever anything you do, it may be a sport, a extracurricular activity, a aesthetic activity, dancing or singing or learning anything. If you don't have this commitment, you won't be able to do that. Only two factors are required to be successful in anything is the discipline and commitment. That's all. Okay, and discipline is not only about remaining silent, continuing the same work schedule, considering the work routine. That's even discipline. Your self-discipline that if you have been given a work routine, you have to obey that. So that is even discipline. Discipline is not always like staying silent and like walking slow. So that is not discipline, what I expect. Okay, so like keep in mind that these like we have to මේ පොඩි දේවල් හදා ගන්න ඕනේ මුලදීම. At the beginning we have to make them and we have to groom and we have to go. පස්සේ හදා ගන්න බෑ. If you come to a 2025 class, you can come in Saturday morning. We had the 2025, not an English medium, no, the single medium class. And like there are around 400 students. But still, if I even go out after giving a problem, and when I come in, like I don't say that the entire one will remain as a meditation center, bhavana madhyasthanak wage ne. But there's no any noise because they're only having exams in like 3 months, less than 100 days. They know what they have to do. 2026 is product in the media. So you are in the initial stage. I'm not asking you to think about A levels. I'm not asking you to like focus on your A levels. A levels අවුරුදු දෙකකින් තියෙන්නේ. 2027 even we didn't have 2026 yet. So you don't have to think about your A levels. But start from here, from this point, start the discipline and commitment. Then it is easy to be successful in anything. If not, like you will be ending up with those mentioned names. Okay, so don't do it 1, 2, 3 bumble. It's really hard because I have this comment even in the single medium class. If you go and ask for any single medium class student who is in the 2026-25 batches, you can ask about the discipline in our class. Okay, so when they compare with other classes, I'm not talking about other combined maths classes, altogether other classes. I have got this comment is because in other classes there is a noise or there is a sound every time there is a noise. And if that noise exceeds a certain level, only the sir will be reacting. I'm not that type. I can't do in that way. Because when I'm talking, if I hear someone talking, if I hear noise, that annoys me. Because I know that if I somehow take you to the track and send you to the track, at the end you will be doing this. මෙතන වැඩ කරන්න බැරි කට්ටිය නේ මම මෙච්චර මේක කියන්නේ. වැඩ කරන්න බැරි කට්ටිය නෑ. වැඩ කරන්න බැරි කට්ටිය මැත්ස් කරන්න එන්නේ නෑ. Everyone here is capable of like doing this and you have a good potential. So it's my duty to mentor you, to guide you. So that's why I want this discipline. And at the end, when you are getting a good result, I don't want any appreciations or any praises from you. Sir, nisa tamai make kare ehmo ne. So that's my job. That is my duty. What I want you to do is focus inside the classroom. Because we have to admit, these days, you're only studying in the classroom. You're only working in the classroom. You don't go home and work these days. No. You work. No, you don't work these days. You don't go home and work. So the only place that you're working these days is in the classroom. So do that. Okay, so single medium they are painless. I'm not like talking about everything about monetary terms. But think about yourself. 5000 ගෙවල ඇයි මෙතන වෙලා ආතල් ගන්න කියලා 1 2 3 බම්බල් බී කරන්න කියලා කොල්ලටි කරන් කියලා බලන්න කොහරි නාවල මේකේ අර this wet park නෙමෙයි වැලි park ඒකට ගිහිල්ලා ගහක් ගාව තියලා 1 2 3 බම්බල් බී කරලා වෙන ගන්න පොඩි ආතල් එකක් පොඩ්ඩක් do that in that way ඕන්න ආය හැරිච්ච ගමන් පොඩි අර 15000 fireworks ටිකක් අරගෙන you can do in that way. Okay, so don't do that don't like ඒ වගේ පොඩි දේවල් වලට no that's wrong. Okay, so I can't see anyone when I'm explaining something, when I ever ask you to do solve a problem, don't talk, just focus on your work. I don't make me repeat this. Because if I repeat it in a different manner, that's why. Okay, so we were talking about composite functions. Okay, so mark my word, if I repeat it in a different manner. Okay, I don't repeat the same thing in the same way twice. I repeat it in a different manner. Okay, so when you're talking about composite function, I told you here the independent variable becomes a function. So inside this function f, we are having another function. So not only two functions, there can be even three functions. There can be even three functions. So inside the g, we got fx. And then inside this f, we have this entire term. So this is how we denote composite function f g x is f naught g. G f x is g naught f. So here the same sequence will be continued. G, G, F, G, G and F. Okay, write in this way. Write in this way. When the independent variable of a function, when the independent variable of a function, when the independent variable of a function is another function, is another function, is another function, it is considered to be, it is considered to be, it is considered to be a composite function stroke function of a function. It is considered to be a composite function stroke function of a function. Okay. Next line, write in this way. A composite function is denoted. A function is denoted in the following. A composite function is denoted in the following manner. In the following manner. Okay, then write this fgx, gfx, fgfx. So few examples. Okay, so make sure that when you have in the same order gf, it's g naught f. So here's like inside g we got gfx, so inside g we have fx. Okay, so I'll explain with example. Now look at this. We have fx is equal to x squared and gx is equal to 2x minus 1. So if I ask you to find fgx, so what is fgx? So this is what we have to do. Lazy. So first write what is gx. Okay, gx is 2x minus 1. So we have to first understand what are the two operations done by these functions. So fx is whatever comes here, it becomes squared. If x is here, it's x squared. If 4 is, if we have something like a, it's a squared. If we have something like 2x, it's 2x squared. So whatever here, it gets squared. What is done by the gx function? So whatever here, it's 2 times x minus 1. So here, if you replace this x by someone, make sure that you replace even this x by the same one. If this x has been replaced, even this one should be replaced by the same one. So now I have f 2x minus 1. So I told you what is the job of f. Whatever comes inside the function, it gets squared. So now if I have f, what is inside f? It's 2x minus 1. So this entire one gets squared. Clear? This entire one gets squared. So what is this? So it's 2x minus 1 squared. The entire one gets squared. That's all. So let's go the other way. We have gfx. A gfx. So first consider what is fx. It's x squared. It's x squared. Okay, now what does gx do? Gx is equal to 2x minus 1. So whatever we have here, now here x has been replaced by x squared. So what did I tell you? Even this x should be replaced by x squared. Should be replaced by x squared. So here, this is equal to 2x will be replaced by x squared. 2x squared minus 1. Clear? X has been replaced by x squared. Okay, hands up if these two again is clear. Okay, now let's see when we have 3. We have f, g and then fx. So I'll explain this. So I want you to do the next one alone. First start from the inner one. So what is fx? Fx is x squared. Fx is x squared. Clear? Okay, so what is gx squared? What is gx squared? X has been replaced by x squared. So what is gx squared? It's 2x squared minus 1. So even you can use this answer because here you have taken the gfx is equal to this one. So you can directly put that answer even. Because we have already taken this, clear? Gfx, we have taken it. So you can directly put this answer here. Okay, now what we have got as f is 2x squared minus 1. So what does f do? Whatever comes in the mukakka, but it squares it. So here we have this one. No? Then if it goes through the function f, this entire one, what happens? It gets squared. So entire one, 2x squared minus 1, it get squared. So here, whatever comes here, it gets squared. So if you understood these three, then I want you to do, when you are doing this question, do g, f, gx. So here, you can either go from the beginning or you can directly import this answer. F, gx, you can directly put this answer. Okay, do this, write the question and then get this. I want you to do this one alone. So you can directly even take this answer. So that's better since you have already taken this fgx. Okay, so here you can directly import this answer. So fgx I'm taking from the first one, that it is equal to 2x minus 1 squared. So what we got here is g, and then we have 2x minus 1 squared. We have gx minus 2x minus 1 squared. So here it's clear what is gx. It's 2 times x into minus 1. Sorry, 2 into x minus 1. So if we have replaced x here by someone, this x should be replaced, because here what get replaced is this one. So x is x. So what get replaced here, it's this one. So here instead of instead of x here, now what we have is this one. So what is this function? 2 into 2x minus 1 squared, and we have this minus 1. So here it's clear, you don't have to simplify. So what happens here? This x, look at this, okay. This x has been replaced by this one. This x has been replaced by this one. Please hands up if you got this correct. Okay, so if I've got it good, if not, let's do the remaining stuff correctly, okay. Do all the 10 questions in question number 3. Small things, just do it. If you got the correct answer, it's good. But if you haven't taken the answer, make sure you take the remaining set correctly. Do all the 10 questions in question number 3. All the 10 questions in question number 3. So here what happens? Inside the g, we got 2x minus 1 squared. So I told you here we got x. Gx is equal to 2x minus 1. Gx is equal to 2x minus 1. Which means it's 2 into this minus 1. You do all the 10 questions in question number 3. First one is fx. Given that f is missing, fx is equal to 2x minus 1. Given that fx is equal to 2x minus 1. And gx is equal to 1 over x plus 1. If you can simplify the answers. If it is, it's in a way that you can simplify it, better to simplify. Okay, so what are the functions that they ask in? First one is f0. So what is f0? Here x should be replaced by 0, which is minus 1. And then g1 means x should be replaced by 1. So g1 is equal to half, 1 over 2. Then we have 2a. So what is f2a? I told you, whatever we have here, it's 2 into that one minus 1. So here it's 2 into 2a, minus 1, clear? So whatever the function we got here should be replaced by, even this x should be replaced. So it's 2 into 2a minus 1, which is 4a minus 1. So everyone is supposed to get these answers. The first 8 That's normal thing. You're supposed to get the answers. So what is G2A? Here replace x by 2a. So it's 1 over 2a plus 1. Replace x by 2a. So there's no any difference between 2a and 2x. So same thing. So what is f2x? 2 into 2x minus 1, which is 4x minus 1. So f2x is same as to f2a, 4a minus 1, 4x minus 1. Then we have g2x, same thing. Here x should be replaced by 2x. So that's all. Here x should be replaced by 2x. X has been replaced by 2x. So even in here, x should be replaced by 2x. Okay, question number 7 is f naught g. Okay, here's the first composite function. So f naught g is fgx, no? It's fgx. I'll do the composite function here. Wait. So what is f naught g? It's fgx. It's fgx. So what is gx? It's 1 over x plus 1. So what is fgx? What is gx? 1 over x plus 1. So here I told you fx is equal to 2x minus 1. So if we have that one, it is 2 into that one who's inside minus 1. Clear? So here when we have this inside f, it's 2 into 1 over x plus 1 and minus 1. So here it's clear that whatever we got here, this one should be replaced even here. So we can simplify. So when you simplify, take 2 as, sorry, x plus 1 as the common denominator. So it's minus x plus 1 over x plus 1. So I get the answer 2 minus x minus 1. So what is my answer? F naught g is equal to 1 minus x over x plus 1. So I can simplify this. What is f naught g? It's 1 minus x over x plus 1. So here it's clear. Whatever we got here should be replaced 2 into that. 2 into that. So whatever we have, it should be replacing this. Got it? Okay. So then question number 8 is, must be g naught f, no? Which is gfx. So same thing, what is fx? Fx is 2x minus 1. So fx is 2x minus 1. Now what happens? Gx is 1 over x plus 1. So here x has been replaced by 2x minus 1. That means it's 1 over 2x minus 1 plus 1. So what happened here is this, we got 2x minus 1 and it is replaced 1 over 2x minus 1 plus 1. So minus 1 plus 1 cancel off. I get it's 1 over 2x. So g naught f is equal to 1 over 2x. Okay, hands up who got these two answers correct. It's okay if you have kept it in this way, but you can simplify. If you have kept this in this way, that's okay, but if you can simplify. Okay, hands up who have taken this and this. Okay. Then when you come to the last one, f naught g, last two, f naught g, so it's f. Inside that we got fgx. So I told you can import the answer since we have taken this. What is fgx? This is this, no? Fgx is this. X 1 minus x, x plus 1. Okay, so then what do you have inside f? You have 1 minus x over x plus 1. Clear? Okay, then whatever is inside fx, what happens? It multiplies by 2 and 1 is subtracted. So what is inside, whatever we got inside fx, it get multiplied by 2 and minus 1. So you can, it's okay to keep in this way, but you can simplify. No? So when I simplify, it's 2 into 1 minus x. If I take x plus 1 as the common denominator, minus x plus 1 over x plus 1. So when you simplify, you get 2 minus 2x minus x minus 1 over x plus 1. So what do I have as f naught g? It's 1 minus 3x over x plus 1. So I have 2 minus x minus 1. It's 1 minus 3x over x plus 1. And then I have, what is the other one? G naught f naught g. G naught f naught g. This is g. Inside that I got fgx. So here you can import the answer. So what's fgx? Fgx. It's this. See? Same. Oh no, same. No, yeah, fgx. Yeah, it's fgx. So inside g, so we can import the answer for this one. It's 1 minus x over x plus 1. Because I have taken this previously. And then what is gx? It's 1 over x plus 1. Okay, now look at this carefully. What happens? It's gx is 1 over. Okay, look at this. Gx is 1 over x plus 1. So whatever comes here, it should be replaced here. No? So now even though we get a fractional one, a big one, look, so even though we get this one, how do we substitute it? 1 over this plus 1. Clear? Got it? So here, with this entire one should be replaced by this one. You can, it's okay to keep in this way, but you can simplify, better to simplify. So when you simplify, it's 1 over, look at this. If you take x plus 1 as the common denominator, in the denominator, it's 1 minus x plus 1. 1 minus x plus 1. So x cancel off. And what happens is this goes to the numerator. So it's equal to x plus 1 divided by 2. Clear. So what do I get as the final answer? It's x plus 1 divided by 2. Clear? Okay. Hands up who got these two. Question number 9 and 10. Okay. So this concludes the lesson functions, but not yet. We have to do more questions. So this one I told you, you don't get these type of questions for past papers. Because normally when we do a question, we do the past papers, the polynomials, we did the past papers. But you don't get functions for the A-level paper. But normally you get functions for your school's first term test, second, and even some schools for the third term test, they have functions. So today I gave you additional paper consisting of school term test questions. So let's do 2-3 questions from that one. For the online students, I think this functions term test question, I saw that they have uploaded in the group. You can take it from the group. The PDF that they have uploaded, functions term test question. Okay, do the first question. Thurston College 2024. Do the first question. So here every question you can do. Start with the first question. You can write you can write the question number, or you can write the school and do the question. So if there's anything unclear related to composite functions or anything else, you can ask me. Do you work alone? If there's anything unclear, you can ask me. තනියෙන් වැඩේ කරන්න clear නැති මොන හරි තිබ්බොත් you can ask from me. If you can't remember to find the domain, like turn the book, turn the pages, and somehow do it a small thing to find in the domain range. Range even we did it today. And then the inverse and composite. So pretty basics, find the domain, range, inverse, and composite ones. Okay. So I'll do the first question. So it's from the Thurston College 2024 paper. So the two functions they have given is fx is x over x minus 1 and gx is x squared. So write down the domain and the range. So I'll write the domain and the range here itself. So domain here, even they have given that x is not equal to 1, no? So it's just right in the domain. They have even given that x is not equal to 1. So then x can be any real number. X can be any real number except 1. X can be any real number except 1. To find the range, I told you what you have to do first. You have to subject x. So how can you subject x here? Is cross multiply, and then you have yx minus y is equal to x. So the basic of subjecting x is that you have to take all the x terms to one side. So that is the basic of subjecting x. Yx minus x is equal to y. So x taken out, it's y minus 1 equal to y. It gives me x is equal to y over y minus 1. It gives me that x is equal to y over y minus 1. So here we have the domain. So if, after subjecting x, it's clear that in the denominator, there is a denominator, which means y can't be equal to 1. So what is my range? My range is y can be any value instead of 1. So this is how you write the range. This can be any value, but it can't be 1. So this is my range. So this is my range. So even you can write this in this way. If you can't remember, you can write this in this way. So your range RF is equal to the entire real number set excluding 1. So you can even write in this way. Even this one you can write the domain is equal to f. Okay, so gx, no any square roots, no any denominators. So then x can be any real number. X can be any real number. To find the range subject x, consider the square root. So I get x is equal to root y. X is equal to root y. So when we have a square root, then you have to make sure that the square root, what is inside the square root should be positive. So this is my range. My range is that y is greater or equal to 0. So everyone got this? No? Hands up if you have taken the domains and ranges. Okay. Then this is question number 1. I'll do question number 3 and come back to question number 2. So then they ask in the inverse. No? Question number 3, they ask in the inverse. Write down the inverse function. So to write down the inverse functions, you can remember, first we need to subject x, because x is equal to f inverse y, and then just change in the variable. So you have already subjected x. You have already subjected. So like don't put Roman number 3 and do it again. You have already subjected. So directly take it. So x here. If you want, you can do it again. That's okay. But not necessary. Y minus 1. So what is x? It's f inverse y. It's f inverse y. So then it is a variable change. Y has been changed to x. I get f inverse x is equal to x over x minus 1. Clear? And then when you find in gx, x is equal to root y. So the inverse of gx, it's not f inverse, okay? It's the inverse of gx, it's g inverse. Okay, not f. Composite function f is equal to ffx. So inside f, what we have, it's, look at this, x over x minus 1. So then, now we have inside fx is this one. So this entire big one, x over x minus 1, should be replaced even here and even here. Clear? So now you know about these replacements. That entire x over x minus 1 should be replaced even here and even here. So what is this? X x over x minus 1, x over x minus 1, minus 1. So here it's clear. What has happened here? This entire one inside fx has been replaced here and even replaced here. So keeping this like according to the functions, that's okay, but it's better to simplify. So take x minus 1 as the common denominator in the denominator, which gives me x minus 1 silence. Because when you simplify, you get a nice answer. That's why. So when you simplify, look how nice it is x minus x plus 1. So x cancel off and it gets simplified. F not f is equal to x. So it gets simplified up to x. If you keep this in this way, like look how ugly it is. But here it's good, nice. X. Short and sweet. Okay, next one is g naught f. What is g naught f? So what is inside g? It's gfx. What is fx? X over x minus 1. So what is, this is easy. So what is gx? Whatever comes here, it gets squared. So whatever comes here, it gets squared. Even when a cockroach comes here, even that cockroach gets squared. So that is what a function do. Whatever comes here, it gets squared. So here, it's equal to x over x minus 1 square. So this is what we have for g naught f. Okay, hands up who got these. If you have written this one, that's okay, but make sure you simplify. Okay, hands up who have got these two composite. Sorry. Then do the next one, Ferguson High School. Where is Ferguson? City? It's in Ratnapur. Okay, no. No, question number 2. Okay, so this one, so they have given, silence. They have given the domain itself, no? They have given that x is R and x can't be minus half. So they have given the domain itself. So here it's 2x plus 1 is equal to not equal to 0. So x is not equal to minus half. Okay. So then what is your domain? Silence. Okay, what is your domain? The domain is x can be any real number, but it can't be minus half. They have given it in a different way. And then you are supposed to find the range. Okay, to find the range, let's subject x here. So when you subject x, silence. Y into 2x plus 1 is equal to x plus 1. So 2xy plus y is equal to x plus 1. So I told you the basic of subject in x. And this one for real, okay? Take it serious. If you find subject in a variable hard, what I want you to do, when you go home, like within this week, get to your O-level maths book, textbook, and there used to be a lesson called formula. Throughout the lesson, you were learning to subject variables. In formulas, you were subjecting variables. So take your maths textbook. If you can't remember, like because we need that knowledge of subjecting, if you can't remember, take the maths textbook and do the exercises there. Exercise 12.1, 12.2, mix exercises, you have to do them. Okay, if you find like subjecting hard, like it's better to do this. Okay, so when you subject, the basic is to take all the x terms together. So take this x here, 2xy minus x is equal to 1 minus 1. So here, when you take x out, it's 2y minus 1 equal to 1 minus y. So what is x? X is, later we want this to the inverse. X is equal to 1 minus 1 over 2y minus 1. Has a who subjected x in this? Good. Okay. So here we are having a denominator. The denominator is not equal to half. Sorry, y can't be equal to half because, sorry, y can't be equal to half, yes. So your range is y can be any real number, but it can't be half. But It can't be half. So this is your range. And then they ask in the inverse. Okay, inverse is after you subject x, after subject in x, then f inverse y is equal to 1 minus y over 2y minus 1. Then it's just a variable change y by x. Silence, okay. I get f inverse x is equal to 1 minus x over 2x minus 1. So this is my inverse, and they ask in the domain of the inverse function. So it's clear the domain of the inverse function here, x can't be half, no? So they're asking, write the domain of the inverse. So what is the domain of the inverse? Here x can be any real number, but it can't be half. x can be any real number, but it can't be half. Okay. So we have taken that inverse and the domain of the inverse. So this is the domain of the inverse. Okay, so if you have completed, you can get ready to go. You can make sure you do all the remaining questions under the functions tut and even in this term test questions. And if there's anything unclear, you can ask from me. Okay. If there's anything unclear, you can ask from me. Okay. Get ready to go. Okay. Okay, silence 1 minute. So make sure you do make sure you do all the homework. The remaining questions in the functions tut. Not that much is remaining, and you can try the questions in the term test paper. And if there's anything that you want me to explain, you can ask me after the class next week. Then I'll explain any question that you will ask. So next week we are starting the new lesson, trigonometry. Make sure that you don't miss the class throughout this trigonometry. The first part of trigonometry, normally it goes for like 8 weeks. Yeah, don't miss the class for even for 1 week, because trigonometry is the most important lesson in PO Maths. If you don't get it properly, you will be suffering throughout this A-level journey. It's like your shadow. Whatever the PO Maths lesson you consider, there is a trigonometry part. So you can't, like in O levels, if you were like not that much good in geometry, you can take out that question out of the 12 questions. You can take out the 2 geometry questions and you can do the remaining 10. But trigonometry is not in that way. Wherever you go, not wherever you go, whatever the lesson you do in PO Maths, there will be a trigonometry part. So make sure that you have to attend classes properly. And in case if you won't be able to attend the class, at least join online or watch the recording. Okay, so next week we are starting the new lesson, trigonometry, and it will be done as a free seminar. Means the ones who newcomers, they can come and they can join the class even next week. Okay, so we are done for today. You can go home.